Here we discuss about the concept like introduction, design features, challenges faced, testing and result, applications, and the conclusion about the unmanned vehicle 1303. Introduction. Unmanned combat aerial vehicles have been an essential part of modern warfare due to their ability to perform various missions without risking human lives. However, maneuvering UCAVs poses a significant challenge to aerodynamics as they require precise control and stability during flight. The aerodynamic studies conducted on the UCAV 1303 during maneuvering will examine the design features of the UAVs 1303 that enables it to maintain stability during high-speed maneuvers and explore the challenge faced by the aerodynamics in achieving this stability. In this presentation, we are discussing about the unmanned compact aerial vehicles, which are very useful for nowadays modern warfares due to every human want to protect himself. So there is going to be non-human wars using the combat vehicles we are going to see in future. The on the basis of the future 10, we are designed this unmanned combat aerial vehicle, that is 1303, and the maneuvering of 1303 have significant challenge over the aerodynamics due to its high speed, how it can be performed during the aerodynamics maneuvers, how the aerodynamic will play a role in the flight of this unmanned vehicle. We are going to see design features. The UCAV 1303 is designed with several features that enhance its maneuverability while maintaining stability. The wings are swept back to reduce drag and improve lift to drag ratio, while the tail fins provide additional aerodynamic stability. The body of UCAV 1303 is made of lightweight material to reduce weight and increase agility. Furthermore, the propulsion system of the UCAV 1303 is designed to provide the thrust vectoring, which allows for precise control of the aircraft during maneuvers. The onboard computer system also play a critical role in the maintaining stability, as it adjusts the control surface and propulsion system in real time to keep the UCAV on course. In this UCAV 1303, there are several features which will tell about the maneuverability and and also use it for the stability of this aircraft. The wings of this aircraft are shipped back to reduce the drag. The drag is a main component in any aerial vehicle. We need to reduce the drag. So the wings of this 1303 unmanned vehicle is swept back, and the improvement of lift to drag ratio will also be caused by the wings are in swept back, while the tail fins provide additional aerodynamic stability. And and when it comes to the propulsion system of the element, which is providing thrust vectoring, which allows the precise control of this aircraft direction during the maneuvers. And by the 1303 is very lightweight because of the material used in it, so the maneuvering will be easily, which increase the agility, which the agility means moving quickly in any direction during the maneuver is called as agility. So due to the less weight material we used in this vehicle, the agility is more. And the onboard computer system, in any unmanned vehicle, the onboard computer system play a crucial role for maintaining the stability, because we need to adjust the controls of the unmanned vehicle by using this computer system. So it play a major role in 1303. And when we come to challenger faced by we are while we are manufacturing this UCAV 1303, despite the advantages design future of the 1303, aerodynamics still faces several challenges in achieving stability during the maneuvers. We all know this. We all know that aerial aircraft have to be in a stable condition to get to get a proper maneuver. While maneuvering, we need to have great stability. So while manufacturing this UCAV 1303, the aerodynamics will have several challenges. On one of the primary challenge in the high speed airflow over the wing, which can cause turbulence and reduce the lift. Due to the UCAVs go with an high speed, the airfoil wing over, then it will produce the turbulence, which means in any aircraft when the air passes through the wing, we need a laminar flow. But due to the high speed of this aircraft, it will produce a turbulence which causes lift will be reduced and the drag is increased. So on primary challenge, this is also come into face. To overcome this challenge, designer uses sophisticated computer simulation to optimize the wing shape and the angle of attack. To overcome this turbulence, to overcome the designers are use the sophisticated computer simulation, which is very essential to optimize the wing shape and the angle of attack. It will change the wing shape and angle of attack of the wing, so the turbulence will be reduced and the lift will be increased. And other challenge is the interaction between the propulsion system and the airfoil around the UCAV 1303. Due to the vectoring producer of thrust vectoring of this propulsion system of this airfoil, the interaction between the propulsion and the airfoil will be various interaction between the propulsion system and the airfoil around the UCAV will be a challenge. And during maneuvering, the thrust vectoring system can create vortices that destabilize the aircraft. Due to the vortices, the aircraft will be destabilized. The aerodynamics must carefully balance the thrust vectoring with other control surface to maintain the stability. So the aerodynamics should balance the thrust vectoring with other control surfaces to maintain the stability of the aircraft. Testing and the results. To test the aerodynamic performance of the UCAV 1303, researchers conducted in wind tunnel tests and the flight test. During the wind tunnel test, the UCAV 1303 was subjected to varying airflow to evaluate its stability and control. During the flight tests were conducted to assess the UCAV 1303 performance in real world conditions. In general, any aircraft was manufactured, we need to conduct the experiments in wind tunnel, and also we need to test in flight conditions in normal natural conditions to face the what challenges it face while traveling in the real world. We need to check what is the behavior of this aircraft during the real world conditions. So we are testing in wind tunnel and the flight testing. During wind tunnel testing, it's subjected to varying airflow to evaluate its stability and control. There is a variation in the airflow while we need to calculate the stability and control. While testing with flight condition, we will know about the aircraft how it will be perform in the real world. The results of the testing showed that the UCV performed exceptionally well during maneuvering, demonstrating excellent stability and control. The results of this wind tunnel test and the flight test was shown that the UCAV 1303 was performed exceptionally well in the maneuverings while rotating, pitch up, pitch down, and that in motions. It was exceptionally well and demonstrating excellent stability and control. The stability of this UCAV 1303 was excellent in the excellent by Excellent. The advanced design features coupled with the sophisticated onboard computer system enables the UCAV 1303 to maintain stability even during extreme maneuvers. Due to the coupling of the sophisticated onboard computer system and the design features of this UCAV 1303 while maintaining the stability, the maneuvering was while doing the maneuverings, the stability is so good due to the coupling of this sophisticated onboard computer system in 1303. And when it comes to the applications of the UCAV 1303, the aerodynamic studies conducted on the UCAV 1303 has significant implication for the development of unmanned aerial vehicles and other aircrafts. The advanced design features and the control system developed for UCAV can be applied to other UAVs, enabling them to perform complex maneuvers with great stability and control. Furthermore, the lesson learned from the UCAV 1303 can be applied to maintain aircraft, improving their aerodynamics performance and safety during the high-speed maneuvers. The research conducted on the UCAV 1303 represents a significant step forward in the field of aerodynamics and has the potential to revolutionize the aviation industry. We need by this UCAV 1303, we have developed a manual. We have developed a UAV which is which is go with a high speed and do maneuvers in a stable conditions. So we can apply these design features in other UAV vehicles also, so we can get the same results from by the other UAVs also. Conclusion. In conclusion, the aerodynamic studies conducted on the UCAV 1303 represents a significant development in the field of unmanned aerial vehicles. The advanced design features and the control system developed for UAVs 1303 has improved its stability and control during high speed maneuvers, paving the way for the development of more advanced UAVs and unmanned vehicles. The challenges faced by the aerodynamics during the development of the UCAV 1303 highlights the complexity of the designing and engineering aircrafts, but also demonstrate the potential for aviation and progresses. The future of aviation looks bright thanks to the backbreaking research conducted on the UCAV 1303. In this conclusion, we are conclude by seeing the performance of the UCAV and how it is manufactured. All this will be a big impact will play on the further UAV vehicles, which is very useful for the further UAV vehicles because we face a lot of challenges while making this UAV. We can apply these to the other UAVs and make them better. In this UCAV 1303, it is having a high stability with high speed maneuvers, which is a significant feature of this UCAV. And by the computer system of this UCAV is also play a critical role in the best features of this UCAV 1303, which we also applied to the other UAV vehicles and increase their stability and control by using the same application as the UCAV are used. So the challenges faced by the aerodynamics during the development of the UCAV, which give the complexity design for the engineering aircrafts, which also demonstrate the potential for the aviation and the progress of the further UAV vehicles. The scientists are put their sweat and blood on doing this UCAV, so which will improve their experience on making the other UAV vehicles also, which will give a better progress for the other UAV vehicles. Thank you. This is about my tech talk.